Time to learn a new programming language, the structured query language. SQL is standardized, based on a specification accepted both by Americans and internationally, but the only people who don't accept it is the people who actually build database management systems. So there are lots of different variants of this language, but mostly the language behaves in the same way, regardless of which database management system you're using. Although these different vendors that produce these big software packages are competing with each other, and so they add various features that the other ones don't add. We'll focus on a part of the language that's universal. A select statement creates a new table, either from scratch or by projecting a table. A create table statement gives a global name to a table. So you can use select in order to create a table, but you need to create table in order to give it a name that you can reuse. And that's all we'll really focus on. Lots of other statements exist: analyze, delete, explain, insert, replace, update, etc. Actually, there are several more. And they're important if you're actually going to use one of these systems in a large industrial application. But they're not too important for understanding the heart of how SQL works. Most of the important action is in the select statement. So we're going to focus almost exclusively on how select works. The code for executing select statements fits on a single sheet of paper. So you can build an interpreter for this language quite easily using Python, and we'll go over the details of that in the next lecture. But first, we have to learn how to use the language. We're going to take a break from Fibonacci sequences and integer sequences and all of that, and instead focus on a theme for the day, and that theme is dogs. I love dogs. I don't actually own this many dogs, but I picked this picture off of the internet because that dog right there looks an awful lot like my dog. If you want to follow along, which I highly recommend, you should install SQLite, which is the simplest and free database management system. You can download it here. There's an online version of SQLite at this address, or if you want, you can use the SQL example Python program from the textbook, which you can find here. It's certainly not as feature complete as SQLite because it's only supposed to demonstrate how to interpret the essence of a select statement. But it will run all of the examples that we'll talk about in this lecture and the next, so that's one option for you to get started. Our first step is to get some data in some tables. And so we'll use a select statement for that, using literal expressions in order to declare which data we want. A select statement always includes a comma-separated list of column descriptions. A column description is an expression optionally followed by as, and a name. So I can say select, expression tells me what I'm selecting, and then as name tells me the name of the column. And if I put a comma there and some more expression as names, then I'll have multiple columns in the result. So this would create a 2-column table. As and the name are optional. You can have more of these. Whenever you're done declaring different columns, you should put a semicolon at the end. All SQL statements end in a semicolon. If you select literals, which are expressions like the number 2 or the string Berkeley, that will create a 1-row table. But if you want to create a multi-row table, you can union together 2 select statements. The union of 2 select statements is another table, but it contains the rows of both. You can only union together tables that have the same number of columns and the same type of information in each column. But the 2 select statements that you union together don't need to have the same names for the columns. It will just use the names of the first select statement in order to name the columns in the final result. Okay, I promised you dogs. Let's pretend I have a lot of dogs. So many that I need to put them in a database. And I like to name my dogs alphabetically, naturally, so that I can keep track of them. And I also really like US presidents. Then I might have a dog named Abraham and a dog named Barack, and I might put those into a table. So a select statement with literals Abraham and Barack will create a one-row table with 2 columns, a parent column, and a child column, and the values that go in those are the values of the literals, Abraham the string and Barack the string. Now if I have more dogs, which I do, then I'll need to union instead of putting the semicolon at the end, and write out the other rows that I want to include in the final result. So if I also select Abraham, Clinton, that will add another row that says Abraham is the parent of Clinton. And over here, I'm just drawing the family tree of all my dogs. Delano is the parent of Herbert, Fillmore is the parent of Abraham, Fillmore is the parent of Delano, Fillmore is the parent of Grover, and Eisenhower is the parent of Fillmore. There is no interesting historical allegory going on here. I just picked this structure arbitrarily, and I picked the names because they go from A to H. So over here on the left is a valid SQL statement, and it will create a table with 7 rows, 2 columns, a parent and a child column, and these are the data that will be stored in those rows. Now, SQL is often used as an interactive language. You just want to see what's in the database. And so, by default, the result of a select statement, or a bunch of select statements union together, won't be stored. The result of a select statement is displayed to the user instead. If you want to store it, give it a name, and be able to use it later, you need a create table statement. So create table just says create table, give the name of the table, and then as, and you can write any select statement there you want. So here's one big select statement. If I write create table parents as, conventionally I will indent this, although that's not necessary. Spacing is totally arbitrary. I've only spaced things out in this way so that it's easy to read. This is also a fully correct SQL statement that creates a table called parents with this data inside. And if we wanted to draw that out explicitly, we might write something like parents with a parent column and a child column and all this stuff inside.